Hello, and welcome to my world of conversation around math topics. My name is Hardy-Soto. I'm the Director of Mathematics for iLead Schools, and today's topic is math roots. You might be asking yourself, what are math roots? I've heard of square roots, I've heard of cube roots. Well, really, math roots is my way of hitting all of those roots in a general way. So first, to understand roots, we need to talk about exponents. And you might ask yourself, why? Well, because exponents and roots are inverse operations. So what's an inverse operation? Well, inverse operations are pairs of math operations that essentially undo each other. So the thing you might be most comfortable with would be addition and subtraction. You know that if you have an addition problem, if you want to undo the problem, you can do it backwards and have it as subtraction. And vice versa, if you have a subtraction problem, you undo it with addition. The same is true of multiplication and division. You can have a multiplication problem, undo it with division, and vice versa. So what we're going to talk about today is what is the inverse operation of exponents. And you may immediately think to yourself, well, that's obvious, square roots. And that's kind of true, but not exactly all the way true. It's only true if the exponent we're dealing with is a 2 or a squared term. And so we'll talk about that a little bit more in a minute. But first, we need to talk about what is an exponent. So you've probably learned that multiplication represents repeated addition. In other words, if you have the problem 2 plus 2 plus 2 plus 2 plus 2, you can also write that as 2 times 5. You're taking 2 and you're adding it 5 times. So multiplication is the repeated addition. Well, exponents are just the step up of that. They're repeated multiplication. So multiplication is repeated addition. Exponents are repeated multiplication. Okay. So in other words, before we had 2 plus 2 plus 2 plus 2 plus 2, now we're going to be dealing with 2 times 2 times 2 times 2 times 2. I think that was 5 times. And that can be written as 2 to the 5th power. The 2 is the base, the 5 is the exponent. So we can either say 2 raised to the 5th exponent, or we can say 2 to the 5th power. Okay. And it doesn't always have to be numbers. We can use variables too. So if you have x times x times x times x, that can be written as x to the 4th power. Okay. Similarly, I bet you can guess if we have 4 times 4 times 4, what can we write it to? 4 is our base because that's what's being repeated. And how many times is it repeated? 3 times. So to the 3rd power. The 3rd power is also known as cubed. So you could say this is 4 cubed. And our last example is 5 times 5, which can be written as 5 to the 2nd power, or this is better known as 5 squared. And this is what I was talking about when I said a squared term would undo a square root. So let's get to it. So now that we know about exponents and we know that they essentially undo roots, we can kind of understand what a root is. So let's start with the last example we shared. We shared 5 times 5 equals 5 squared. So if we go forwards, using the exponent, 5 times 5, and we write it with the notation, that's 5 squared, and we know that that equals 25. If we're going to go backwards, the opposite of this squared term is the square root. So we have square root of 25. We start on one end and we go backwards. We can break the 25 into 5 times 5, and we know that the 2 5s is really another way of writing 5 squared, and this squared will undo the square root. So essentially the answer of square root 25 is 5. Just as 5 times 5 is 25, the square root of 25 is 5. Our next example. Oh, before I go into the next example, I want to point out, we notice the exponent here is a 2, but we don't really see a 2 here. And what I want you to understand is that when we have a square root that you don't see a number here, we know that there's an invisible 2 there, which is what makes it a square root. That's kind of the default, okay? But our next example, now we're dealing with the 3rd power, or cubed, 4 times 4 times 4. So we're going to deal with the cubed root. And you understand now why I said it's not just square roots. It's going to be whatever the root is that undoes the exponent. If our exponent is 3, we need a 3rd root because those are the inverses that will essentially undo each other, okay? So if we have the cubed root of 64, which is what we started with here, we can break that down into 4 times 4 times 4. There's 3 of them, so our base is 4, and our 3 is the exponent because we multiplied it 3 times. That can be undone with the third root, and our answer is 4, just like we started with 4 on this side. Okay. Same thing with the x's. X times x times x times x is x to the 4th. We can't give you what that equals because it's a variable, so we don't know yet. But we can undo it. We know that the 4th exponent will be undone by the 4th root. So the opposite is you take the 4th root of x times x times x times x, which is x to the 4th, and the 4th exponent will cancel out or be the inverse of the 4th root. So we get x as the answer. And finally, our last example was the 5 2s. So 2 to the 5th. Now be careful, because I know a lot of you will see these problems and you're going to automatically say, oh, 2 to the 5, that's 10. It is very common for kids to just go immediately to multiplication. Even if you know differently in your head, it's like automatic. So you have to be really conscious about it and tell yourself, no, this is not multiplication. This is not 2 times 5. This is not 10. It's actually 2 times 2 times 2 times 2 times 2, 5 times. And that is 32. The same goes for any of these. You know, 5 squared is not 10 either. It's 5 times 5, which is 25. Okay, so I'll get off my rant there. But now the opposite of this, because we use the 5th power, is going to be the 5th root. So the 5th root of 32, we could break it down into its parts. There's 5 of them to the 5th power, and the 5 and the 5th root undo each other. So we're left with 2 as the answer, which was our base. Okay. One thing to point out, it's almost like, if you want to remember it in a cutesy way, the exponent is like the key that will unlock the root gate. So if you have a root gate of 3rd root or 3, you want the exponent to be 3. So your key can unlock this gate and let the 4 out. And once the key and the gate cancel each other or undo, then we know the 4 is outside of the gate by itself. Same thing here. This 4 undoes the 4 root or the gate, and the x is left by itself, and the 5 unlocks the 5 root. So that's a fun way, easy way to remember it for you. Okay, so let's have some practice. How would you solve the 3rd root of n times n times n? This seems like it'll be pretty basic. The idea is you could either say, well, it's a 3rd root and there's 3 of them, so I know the answer is going to be n, because I understand that that's how it works. We're just getting the base. Or if it's hard for you to see that, you can say n times n is n to the 3rd, and you can take this 3 and unlock the gate, and you'll get n as your answer. Okay, you want to try another one? And by the way, feel free to pause this video in between. So when I give you the problem, you can try it on your own and then see what I've put to see if it matches up. Okay, 4th root of 81. A lot of times you don't know what to break it into off first hand. So you might think to yourself, well, let me just break it down into multiplication pieces so that I know what the multiplied parts are. So 81, a lot of people know is 9 times 9, and that's fine. You can start there. 9 times 9, but it's a 4th root, so we need 4 things that are all the same, right? Well, 9 is 3 times 3. So essentially we have here 3 times 3 and 3 times 3. So let's write that. And now you can see we have 4 of the same thing. So we could write it as 3 to the 4th, and the 4 will unlock the 4th root gate, and my answer will be 3. Did you get that? Okay, let's try another. Root 64. Now again, you might think, well, hold on a second. What's the number on it? But remember, anytime there's no number, it's automatically a 2. It's a square root. So how can we break down 64 into 2 things that multiply to be each other? How about 8 times 8? 8 times 8 is 64. So again, we can make that the 8 squared if you want to see the key to unlock the root. And remember, there's no 2 here, but secretly there is. So the answer is 8. All right, let's try another. The more examples we can see, the better we'll get at this. So this one is asking for the 3rd root of 16. Okay, well, we don't know where to start, but we know at least we need to break down the 16 into its multiplied parts. So 1 we know is 4 times 4. Let's break it down into 4 times 4. Okay, well, we don't have 3 of the same thing, so we got to break it down further. Well, we know 4 times 4 is 4 is 2 times 2. So we have 2 times 2 and 2 times 2. And now you may think, oh, we have 4 2s, but we only need 3 to unlock the gate. And so this gets a little tricky here. But when it comes to third roots, we need the third exponent, even if you have more. So what happens is you can group them. You can take these 3 here and say that's 2 to the third. And then there's this last 2 left over. 2 to the third, this last 2 left over. So in this case, this 3 unlocks the 3 gate. This 2 escapes, but this one is still left under the root 3 gate. So this 2 escapes, you see it right here, and this one is left underneath the root 3 gate. Okay. All right, let's try a couple other ones. How about this one? Root 3 to the, with n to the 8th power underneath. Now I want you to get a little bit flexible with how you think about math, because you could easily write out n times n times n times n times n times n 8 times, right? But also you could think to yourself, okay, we want groups of 3 because we need to unlock the 3 root, okay? The third root. So we could break n to the 8 down into n to the 3 because that's n times n times n. And then another n to the 3, n times n times n. And that leaves 2 left to get the 8 that are underneath there. So does everybody agree this is fair to write it this way? And in that case, this 3 will unlock the lock and this n will get out. This 3 will unlock the lock and this n will get out, but this won't. The n squared will stay underneath the third root. So let's see what that looks like. So this n got out, this n got out, but the n squared is still underneath there. And we got to take it one step further because technically we brought it out in multiplied parts. 2 of them got out, but we can multiply them together. So this would be n squared on the outside, and then the third root of n squared. Let's try another problem. This one I love because I think a lot of you will see the 4, the root 4 and the 64 and say, oh, this one's going to be easy. It's going to go in evenly. Because again, we tend to go to that place where we think of what we're doing here as division. And we say, oh, 4 goes into 64 easily. But this is the 4th root. So this is very different. So let's see what this one looks like. So again, if we don't know where to start, we can just start breaking that number underneath into multiplied parts. So 8 times 8 is 64. And we say that's not enough. So let's go further. Well, I know 8 is 4 times 2. So 4, 2, 4, 2. And again, we don't have 4 of the same thing. So let's break it down further. Each of these 4s can be 2 times 2. So we're going to get 2, 2 and 2, 2 with the 2s that were already there. So there's 6 of them, right? Okay. So now we say, wait, but we need 4 to unlock the gate. So we're going to take 2 to the 4th here. And these 2 squared are going to be left under the gate. So let's see. Here it is. 2 to the 4th, 2 squared. This 4 can unlock the gate and let this 2 free. And the 2 squared is still stuck underneath. And this is a totally legit answer, but you might need to do the 2 squared underneath back to a 4. Your teacher might require that. And that's fine too. Okay, one more example, square root of 100. Now, a lot of you may say, well, square root of 100, that's easy. 10 times 10 is 100, so square root of 100 is 10. And that is absolutely true. So if that's the way you went, fantastic, nice, quick, easy. But I want you to not get hung up on only doing things one way. A lot of times kids get stuck because they feel like I can't think of the right way. And there's a lot of right ways to solve these. So I want to show you a way that's a little bit longer, but show you how it'll come out to the same 10 that you got if you just realize that it's 10 times 10. So you don't have to panic about doing things wrong. So let's say I broke this 100 into 25 times 4. And then I said, okay, that's not enough. I got to break it down further. So 5 times 5 and 2 times 2. And then I say, okay, I can make this 5 squared and 2 squared, and those will each unlock the squared gate. So here we go. So this will unlock, and the 5 will be set free and the 2 will be set free. But remember, when they come out, it's not like it's 52. The 5 and the 2 have to be multiplied because they were multiplied on the inside. So when you pull them out, they're still multiplied. Okay. So we end up getting 5 times 2, which is, surprise, surprise, 10. So I want you to realize that even if you take a longer route, as long as you're doing legit math moves, you'll still get to the same answer, okay? All right, and finally, if I have root 3 over 20, and I say, okay, let me break this down. Okay, 5 times 4, I know that's 20. And it's not enough, I don't have 3 of the same thing. So let's break down the 4 further. So now it's 5 times 2 times 2. But at this point, these are all primes. We can't break down 5 or 2 any lower. We could keep doing times 1 times 1 times 1, but that would go forever. So this is kind of the lowest we can go. And at that point, we have to realize that's not going to work with a root 3. And so we just go back and we leave it the same. So I wanted you to realize that's fine too. If you try to break it down and it's not breaking down, sometimes that's as far as you can go. Okay, I want to leave you with one last thing. And that is, what can you do for the numbers that don't come out even or nicely, okay? So I'm going to start nice and easy. Let's talk about root 5. So let's pretend we needed to know root 5. We can't break it down. The square root, we need 2 of them. This isn't working. We can always estimate. So we don't, let's see, root 6, that doesn't come out even, root 7, root 8, but root 9. What is root 9? Root 9 is 3 times 3. Well, 9 is 3 times 3. So root 9 will give us 3. Does everybody see that? Okay, then you could think, what's a root that's lower than root 5 that would come out evenly? And you might think root 1, because that's 1 times 1, right? And you're absolutely right, but try to get the roots that are as close to the 5 as you can. And there's another one that's a little closer. And that one is root 4, right? That's 2 times 2, and it's a little closer to the 5. So we can get rid of this one. We could break the 4 down, 2 times 2, 2 squared. This 2 unlocks the gate. So we know that root 5 is somewhere between root 4, which is 2, and root 9, which is 3. So the answer to root 5 is going to be somewhere between 2 and 3. And we know it's a little closer to the 4, because 5 is closer to 4 than 9. So that means the answer is going to be a little closer to the 2. So we can kind of estimate and guess, maybe 2.1, maybe 2.2, maybe 2.3. Something in that range is going to get you pretty close to the answer. These are all really good estimations, okay? So you want to kind of get good at knowing about what it's in between. If you want the exact, you can always plug it into a calculator, but this is a really good skill to have to kind of have an idea of where it's going. Okay, let's go a little more difficult. Again, this is to show you how you can do things in many different ways and come to the same answer. So root 28, we can kind of do the same way we did before. I can say 36 is a little bigger. It's the biggest one I can think of above it that is even. So 36 is 6 times 6. 6 squared is 6. And then 25 below it, because that's 5 times 5. So I know that the root 28 is somewhere between 5 and 6. 5 point something, right? Now, 28 again is closer to the 25. Not as close as before, but pretty closer compared to the 36. So my guess this time might be 5.2, or maybe 5.3, maybe 5.4, something like that. We know it's going to be something in there, okay? Or if you went this way, you could always break down the 28. Now, what I just did was fine, and you can do that too, but sometimes the numbers are going to be really big and it's going to be hard to find the squares. So you're going to want to break it down first. So let me show you how that would work with this one. So 28, we could say, is technically 7 times 4. And the 4 can break into 2 times 2. Now we have 7 and 2 squared. So the 2 can undo the lock here, and the 2 can escape with 7 still stuck underneath there. And now we can do the same game that we just did for the 7. We know again that it's somewhere between 4 and 9, but a little closer to the 9. So it's going to be between 2 and 3, but a little closer to the 3. And so technically the answer to this is going to be 2 times something that's a little closer to the 3, which again will be somewhere between 5 and 6. And we guessed before, right around like 5.4, something like that, it would be essentially the same. And remember, this isn't for perfection. This is just to get an idea of about where it would be, because the more you're able to do that, the more you will understand and comprehend how numbers work together in math, and you'll have a better idea of what to expect. Okay? All right, that's all I have for you today. I hope that this helps, and I hope that you have a really good time playing with roots, with math roots. All right, happy mathing, everybody. Have a beautiful day.